Everyone. Today we'll be covering the histological organization of the bone. Our presenter will be Yusvat Kimani, and I'm obliged to take you through this crucial topic of anatomy, that is the histological organization of the bone. The scope for the session will be define the bone and what's a bone tissue. We'll look at the general structure of bone, that is both grossly and also histologically. We look at the cell types of the bone tissue. So these cell types of the bone will be the cells that we will be able to see them histologically. Then we'll see what are the various types of bone tissues, and then we'll talk a little bit about bone formation. So let's go ahead and define bone tissue. So bone is a specialized type of connective tissue. Normally, connective tissue usually have connective tissue proper and then specialized connective tissue. So specialized connective tissue characterized by mineralized extracellular matrix that stores calcium and phosphate. So the last bit, mineralized that stores calcium and phosphate, is very important. Remember, the difference between cartilage and bone is that cartilage is not mineralized, but for the bone is mineralized. What are the functions of bones? So bones are hematopoietic centers and formation of blood. You can appreciate that. So bone marrow contains stem cells for formation of blood. Then you have storage of minerals such as calcium and phosphates. We talked about mineralization that happens in the bone. So ideally calcium and phosphate are stored in the bones. Protects vital organs of the body. You find that, for example, the skull protects the brain, which is a very important neural structure in the body. And so attachment of muscles and tendons. And through that attachment now, that's the reason I will be able to have movement of the body and movement from one place of the body from one place to another is by attachment of muscles and tendons to the various bones. Then it gives the body its shape and also supports the body. So some of the functions of the bones are very important. One is hematopoiesis, storage of minerals, shape and support of the body, movement of the body. And of course, not the rest, protect vital organs, site of attachment of muscles and tendons are also important functions of the bones. What is the general structure of a bone? The general structure of a bone is that it's an organ, so that because it has blood vessels, it has fat in the bone marrow, and then it is a hemopoietic tissue. So given that it has blood vessels, it requires nutrition and removal of waste. In addition to that, as a bone, it has innervation, it has nerves that innervate it, and then it has storage of fat there, and then it is a hemopoietic tissue. So formation of blood happens in the bones, bone marrow. Then these blood vessels run in a canal, and this canal, Haversian canal, are vertical canals, and then Volkmann's canal, they are vertical canals. Sorry, they are horizontal canals. So Haversian canals, they are vertical. Then Volkmann's canal, they are horizontal to one another. And that's the reason why now we have branches of arteries, veins, and even some nerves passing through these channels. See here. Then it will have periosteum and endosteum, which are cellular. So the periosteum and endosteum are outer and inner lining respectively. So on the outer lining, we'll be having periosteum. On the inner lining, we'll be having endosteum. And all those two are cellular. That means if you have an injury there, you'll feel pain because they are cellular and then they are innervated, especially the periosteum. So an injury to the periosteum, a fracture to the bone, will be very painful because of the innervation of the periosteum. At least you can appreciate the general structure of a bone. You have epiphysis on both ends. Epiphysis on both ends, then you have diaphysis, the shafts. Then you'll have medullary cavity, the one that stores, has the bone marrow. Then you have the spongy bone, the cancellous bone. You have a fissure line here representing the epiphyseal growth plates. we have the articular cartilage on the joint cells. So, for example, now this is a femur. We'll have articular cartilage for the hip joint, and then articular cartilage for the knee joint. If this is a humerus, so appreciate that here we'll have articular cartilage for the shoulder joint or the humeral joint, and then at this point we'll have articular cartilage for the elbow joint. At this point, you can appreciate this the general outline of what we talked about. You can appreciate this Volkmann's canal, which is horizontal, and then you have aviation canals, which are vertical. So these canals have blood vessels and nerves passing through them. We'll talk about the spongy bone in a few minutes, and also we'll talk about osteocytes, the osteoid, and also the canaliculi clutch. The same thing you can appreciate that this is a bone, the humerus. It has an outer covering the periosteum. Then you can appreciate the blood supplies through the nutrient artery, which pierces the humerus. Remember, this nutrient artery of the humerus comes from the brachial artery. Then you'll have the compact bone at this point. Then at this point, you'll have the cancellous bone. So these periosteal arteries are the ones that penetrate and go and supply the bone marrows. Then you'll appreciate you'll have metaphyseal arteries. These metaphyseal arteries will be coming from nearby arteries. Then another point to appreciate is that we'll also be having the effusion supplying the bone in terms of nutrition and also removal of waste. We now down to the osteoid. Remember, the osteoid is a functional unit of a compact bone. So it will have a aviation canal with a nerve and blood vessels, an artery and a vein, and then it will be surrounded by 4 to 20 concentric rings. So these concentric rings are usually known as lamellar system. So this is a aviation system. So the aviation system will contain a aviation canal, 4 to 20 lamellar system, and then you'll also have blood vessels and nerves inside the aviation canal. Another point to appreciate is that we'll have osteocytes. Osteocytes is one of the cell types in the bone. So osteocytes will be found in the lacunae, as you'll see in a few minutes. So you'll see osteocytes surrounding the aviation system. So I will find that the lamellae will be containing the osteocytes inside them. So physiological organization of the bone at this point, it has cells and mineralized matrix. So cells, which cell types? We'll see in a few minutes. And then mineralized matrix. This mineralized matrix comes from inorganic matrix, which is calcium hydroxyapatite. So this calcium hydroxyapatite is being made by calcium and phosphates. Is the one that is being deposited on this matrix. So you'll see cells in lacunae, as you can see here. These are osteocytes. This is an osteocyte in lacunae, and then it has cytoplasmic extensions. And these cytoplasmic extensions are the ones that will communicate with other osteocytes through gap junctions. So cells in lacunae and some lining cells will appreciate that inside here we'll have cells in lacunae, the osteocytes, and then you have outer lining cells. These outer lining cells will be periosteal cells, and inner lining cells will be endosteal cells. The extracellular matrix will have organic and inorganic fibers. So for the organic fibers, we talk about the collagen fibers. We talk about collagen type 1, type 3, and type 5. Remember, type 5 is the most common. Type 1 is the most common in bones, but the one that is typical and found only majorly in bones is actually type 5 collagen. For the inorganic component, we have now the calcium hydroxyapatite, the mineralized part that will make this matrix of the bone to be compact. Talking about the various cell types. For the various cell types, we have about 6 cell types. The most important one is the osteocyte. But before then, we have osteoprogenitor cells. So osteoprogenitor cells are the stem cells. They are the ones that give rise to all the other cell types, and we have the osteoclast. So the osteoprogenitor cells, they are stem cells that are liable for bone growth. Then you have osteoblasts. These osteoblasts are the ones that secrete osteoid. So they are in charge of bone synthesis and bone mineralization. So in short, in simple terms, the osteoblast lay down matrix. Then the osteocytes, they maintain the bone matrix. Remember, osteoblasts, after secreting osteoid, they become osteocytes. And that osteocyte now is the one that will be inside the lacunae. It will be inside the lacunae. And maybe a question that I can pose to us is that what are the phases of osteocytes development? So though the three stages of one of osteocyte development, we can have them in our fingertips. Then for the osteoclast, these are bone resorption. They have function on bone resorption and remodeling. These osteoclasts, they don't come from the osteoprogenitor cells. They are from the bone marrow. So they have lineage that comes from the monocytes, the osteoclasts. Remember, these are the macrophages for the bone. Then the bone lining cells, you have two inner endosteal and outer periosteal cells. So these cells are liable and they just provide the function of nutrition to the other to the bone and to the bone marrow. So you'll find that they are very active in terms of protein synthesis, in terms of nutrition to the other cell types. At this point, you can appreciate that this is an osteoclast. So they are usually binucleated. You have osteogenic cells, and the osteoprogenitor cells, osteocytes. You can appreciate the cytoplasmic extensions, and then you have the osteoblasts at this point. So these osteoblasts are the ones that will secrete matrix, and then they will give rise to the osteocytes. At this point, you can appreciate the various cell types. We can start with the inner endosteal cells, then the outer periosteal cells, and appreciate the osteoblast, which will give rise to the osteocytes. Osteoprogenitor cells will give rise to all the other cell types. Remember, osteoprogenitor cells will become from mesenchymal stem cells. And these mesenchymal cells are not differentiated. They are not directed in any kind of direction. So these mesenchymal stem cells can be osteoprogenitor cells, they can be chondroprogenitor cells. Osteoprogenitor cells will give you the bone. Chondroprogenitor cells will give you the cartilage. So these mesenchymal cells are not differentiated. And you will have kind of direction where you have osteoprogenitor cells. In osteoprogenitor cells will give you osteoblast, and osteoblast will give you the osteocytes. My point to realize is that these, the granulocytes, the monocytes lineage, are the ones that will give us osteoclasts. So remember, osteoclasts will be formed by merging of a few inactive osteoclasts to become active osteoclasts. That's the reason why osteoclasts will have more than one nucleus. For the histological organization of the bone, you'll appreciate it has lamellar system. So you can appreciate here is the lamellar system. So these are the concentric rings. For example, you can appreciate here is the avation canal. Then you have rings surrounding the avation canal. These are the lamellar system. For the lamellar system, you can have one, for example, this one is the avation because surrounding the avation canal. Then you'll be having now others in between the avation canals, we call the interstitial lamellar system. And now you have a large one that will be encircling. They have various avation canals. We have inner circumferential and outer circumferential lamellar system. So in simple terms, you have both three. Lamellar system, avation, interstitial and circumferential. And pressure is avation. In between two avation canals, we'll be having, in between two avation system, we'll be having interstitial. And then others that will now be encircling both the avation and interstitial will be called circumferential because it's winding around the avation and interstitial. So you can have inner circumferential and outer circumferential avation system. The functional unit of a bone is of a compact bone is an osteon. So you can appreciate here is an osteon because we have avation canal. We'll be having its blood vessels and nerves. and you'll have concentric rings, the aviation system. Then you appreciate these black spots are actually osteocytes in lacunae. So osteocytes in lacunae will be found inside the lamellar system, as you can see here. So these are actually the osteocytes. This is clearly seen in this. You can appreciate here is an osteon. So this osteon will be having a aviation canal. This aviation canal will have the blood vessels and also nerves. And then these are same aviation canal as you can appreciate here. Then you appreciate that there will be fibers. There will be a lamellar system circling it. So these are aviation system. And then you can also appreciate that you have cells in lacunae, as you can see in this. So these are osteocytes, in lacunae, and then you can appreciate the cytoplasmic extension for communication with nearby cytoplasmic osteocytes. You can appreciate this aviation canal. At this point, you have the interstitial, and then you have the outer circumferential. So those are the various lamellar systems, as you can appreciate there. For the compact bone, you can appreciate how it looks like. It's a compact bone. Histologically, you appreciate something like this. You can appreciate his aviation canal, and then you have the aviation system, the various concentric rings. So at this point, you can see that this is the interstitial lamella, and then you have the various concentric rings, giving you a definitive of a compact bone. We have two histological types of bones. We have cortical bones and cancellous bones. Cortical bones, you can appreciate this on the outer part, cortex, cortical bone. So these cortical bones, they'll be found in areas where you have compression and tension. And this is what is present is absent in children and young units. So you find that children will have bones which are not that compact because they haven't undergone stress. When now the bones undergo stress, they have cortical bones. They will become cortical in nature. And hence, these cortical bones, when they undergo a lot of pressure and compression, they will break. And that's the reason why in children having fractures is not a normal thing. But when fractures happen in adults, they are very painful and then they are catastrophic as appreciated in this. And cancellous bones, they transfer load away from the joints. For example, you can appreciate here. So here you have the hip joint, and then here you have cancellous bones, enabling you to transfer load from the joint. So from the hip joint down to the shaft of femur, as you can appreciate that. So cortical bone, when you have the bone marrow, the cancellous bones, and then the function of cortical bone is just to prevent compression and tension, and then cancellous bones, or the spongy bone, enables the transfer of fluid away from the joint. As appreciating this, is an example of a cortical bone, a characteristic of a compact bone, and then you also appreciate that this is a cancellous bone. So in cancellous bone, you'll be able to appreciate the bone marrow. So this is a bone marrow. This is a red bone marrow. You can appreciate the osteoclast. You can appreciate the osteocytes in lacunae. Then there's a bone matrix at this point. So in this, if we can go to higher magnification, we find all the 5 cell types of the bone. We'll have a brief comparison between cartilages and bones. So remember, cartilages are soft, flexible, and elastic. Then bones are hard, inflexible, and tough. Then matrices in cartilage is homogeneous in nature, unlike in bone, which has lamellar system. Then cartilage will have only cells in the lacunae, that is the chondrocytes. But on this other end, the bone will have both cells in lacunae, that is the osteocytes, and also bones on the lining walls. Then another point of appreciate is that the cartilages will be avascular and can undergo degeneration. It's undergoing degeneration because it's avascular. And then the bones, which are vascularized, can undergo regeneration. The reason is they are vascularized. Then another point to appreciate about extracellular matrix of the cartilages is that you have fibers glycosaminoglycans, protoglycans, and multi-adhesive glycoproteins, which are arranged at a certain function, unlike in extracellular matrix in bone, which is mineralized due to the crisis of calcium hydroxyapatite. Our point about extracellular matrix is that has structural adaptations, the fiber arrangements, that is, especially in the cancellous bones. The cancellous bones will have projections towards one another, unlike in cartilages, which is not present. Then grow this bidirectional cartilages, and then on bones, they grow this unidirectional. Some of the cartilages will have perichondrium, and bone doesn't have perichondrium. It will have inner lining, that is endosteum, and then outer lining, which is the periosteum. So another point of operation, both also the periosteum will have inner lining, inner cellular and outer fibrous components. Regarding bone formation, can appreciate bones developed by either two endochondral ossification and intramembranous ossification. Endochondral ossification will give you the long bones, and intermembranous ossification will give you some of the irregular bones. So examples of bones formed by endochondral ossification will have femur, humerus, ulnar radius, tibia fibula, and even the phalanges. And the ridges will be coming from the endochondral ossification. Intermembranous ossification in some of the bones include most of the bones of the skull. Talk about the parietal bone, talk about the temporal bone, the frontal bone. All those bones will be coming from intermembranous ossification. So how does it happen? All of them will have the osteoprogenitor cells. So condensation of mesenchymal cells. These cells condense they form osteoprogenitor cells. So in endochondral ossification, we'll have hypertrophy of the chondrocytes. They hypertrophy, and then you have now bone plates, the hyaline cartilage plates, which will undergo vascularization, and you'll have growth. Remember, in growth, you'll have now the epiphyseal growth plate coming in, and then you'll have deposition of calcium in them. In intermembranous ossification, you just have a blood vessel carrying the osteoblast. The osteoblast is the one that lays down the matrix, giving you the bone lattice, then the bone lattice expands. So it's just a brief overview of what happens during bone formation, starting with endochondral ossification. You have the hyaline cartilage models with plates happening, then you'll have the vascularization happening, and then you'll have now the osteoblast laying down the matrix, and then ossification happens, giving you definitive bone growth. The membranous ossification types of bones, parietal bone, bones of the skull most of the times. And then you have bone vessels, blood vessels, which gets in touch with the condensation of the mesenchymal cell. It will nail down the matrix. When it lays down the matrix, will undergo expansion of the condensation and also bone lattice being laid down, and then have the expansion of the bone lattice. So that's about the two types of endochondral ossification. And then that is it. So I hope you've enjoyed the session. That's basically about bone. So kindly do well in your exams. I wish you all the best. Kindly like, share, and subscribe to your friends. Thank you.